Hello everyone, welcome to Mathematics Step by Step. I am Yin. So today we'll start this chapter 5 on network in graph theory, okay? So I believe this is a brand new chapter for every one of us, okay? This is just included in the new syllabus, okay? So today we'll learn to identify and explain a network as a graph, okay? So we can see a graph looks like this, okay? It has vertex. These dots are called vertex, okay? Then the line joining the dots are called an edge, okay? So a graph is used to represent data consisting of discrete objects and to show the relationship between these objects in a simple graphical manner. In the field of mathematics, graph theory in particular, a graph is interpreted as a series of dots which are either linked or not linked to one another by lines, okay? So meaning that this is a graph also, although there is no edges, meaning there is no lines connecting the dots, okay? So each dot is known as a vertex and the line joining two vertices is known as an edge, okay? A graph is usually used to represent a certain network. So a network is part of a graph with the vertices and edges having their own characteristics. The structure of network data has a many-to-many relation, okay? So at the back of this chapter, we'll learn more on this. So examples of graphs that involve networks are as follows, okay? So land transport network, social network, okay? All these are like the vertices, okay? Then all these are the edges. So a graph is denoted by a set of ordered pair, where V is the set of dots or vertices. So in chapter 4, we learn about sets, right? Whenever we want to represent a set, we'll use this curly bracket. So same goes to V. V is the set of vertices, okay? So we'll use this curly bracket. And all these are the vertices of a graph, okay? E is the set of edges or lines linking each pair of vertices. So again, it is a set. So we'll use this curly bracket. Or we can write this also, okay? To represent an edge, where A and B are the pairs of vertices, okay? So later we'll see more on this in the examples, okay? So the degree D is the number of edges that connect two vertices, okay? So let's say this point and this point. This is the first edge, this is the second edge, this is the third edge, okay? So let's say this point called P, this vertex called Q, okay? So the degree for vertex P is 3 because there's 3 edges connecting these two vertices, okay? Then this formula is used when we want to calculate the sum of degree, okay? Sum of degree is twice the number of edges, okay? So now, what do you understand about a simple graph? A simple graph has no loops, okay? Loops is like this. The line comes out from this vertex, then go back to the vertex itself, okay? And there is no multiple edge. This is a multiple edge, okay? Because there are 3 lines connecting these two vertices, okay? The sum of degrees of graph is twice the number of edges. So this is what is shown with this formula, okay? So let's go through this example 1 together so that you can understand better. Based on the simple graph given, determine V. V is the set of vertices, okay? So in this case, we can see all these dots are the vertices and they are named after 1, 2, 3, 4, 5, 6, okay? So the set of vertices is 1, 2, 3, 4, 5, 6. Then NV, number of elements in this set is 6, okay? This is what we have learned in chapter 4. So again, if you guys are having problem understanding this, you can go through again my video on sets, okay? So now, E is the set of edges, okay? So like in this diagram, the edges are not named, okay? Sometimes we can see the edges are named after, for example, E1, E2, okay? But in this case, there's no name for the edges. So we will use this method to name the set of edges, okay? So let's see this line. This line is connecting point 1 and point 2, okay? So we will represent this edge like a coordinate, okay? Like this. Then this line connecting 1 and 5, so we'll write like this, okay? 1, 5. So on and so forth for the other edges, okay? So now we can see that there are 7 edges. Then let's calculate the sum of degree using this formula that we have learned just now. Sum of degree equals to 2e. So e we have found equals to 7. So 2 times 7 gives us 14, okay? So we can refer to here for vertex 1, the degree is equals to 2. So we can see this is the first line and this is the second line connecting vertex 1, okay? The degree of vertex 2 is equals to 3. Vertex 2 is here. So we can see this is the first line connecting vertex 2, this is the second line, this is the third line. So the degree equals to 3, okay? So on and so forth. So now, let's look at this info zone. The edge for the vertex 1, 2 is also the edge for the vertex pair 2, 1, okay? Because we can see that this graph is a simple graph and there's no direction, okay? There's no arrow on these edges. So for this line, let's say, okay, we can write either 1, 2 or 2, 1, okay? They are representing the same edge. So now let's go through this example 2 together. State the number of vertices, edges, and the sum of degrees for the following simple graphs. So let's look at A. Vertices are all these dots, okay? So number of vertices is 7. Number of edges, 1, 2, 3, 4, 5, 6, 7. Number of edges also 7. So sum of degree. Sum of degree is this formula equals to 2e, okay? There are 7 edges, so 2 times 7 gives us 14. This is how we came to this answer, okay? Let's proceed with B. Number of vertices. So now the vertices are named after A, B, C, D, E, F, G, okay? So there are 7 vertices. Number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So number of edges is 9. Then again we use the formula sum of degree equals to 2e equals to 2 times 9, which is 18. Okay? This is how we get this answer. So what is the meaning of multiple edges and loops? Okay, just now I have gone through a little bit very quickly, so now we'll go into it more detail. Okay, so multiple edge, we can see there are 2 lines connecting vertex P and vertex T. Okay, this is the first line, this is the second line, so here is a multiple edge. Then this is a loop. Okay, we can see it comes out from vertex S and goes back to vertex S itself. At vertex R, this is also a loop, okay? Comes out from vertex R and back to itself, okay? So a multiple edge involves 2 edges. The vertices are connected by more than 1 edge, and the sum of degrees is twice the number of edges, okay? Then loops involve 1 vertex and the edge is in the form of an arc. The starts and ends at the same vertex. Each loop adds 2 to the degree, meaning that this loop is count as 2 degree. Okay, so let the graph given be denoted by a set of ordered pairs GVE. Okay, so now let's refer to this diagram. Okay, so the set of vertices, we can see they are named after A, B, C, D. Okay, and now the set of edges, we can show it this way or this way also can. Okay, I personally prefer this method more, okay, because it's easier. You can see in this case the edges are named after E1, E2, E3, E4 and so on. Okay, so this is the method that we can use to show the set of edges also. Okay, so now let's go through example 3 together. The diagram on the right shows a graph with a loop. So we can see the loop here at vertex S. Okay, and multiple edges. So this is a multiple edge. Okay, connecting vertex P and U. So now A, let's state the set of vertices. So vertices are all these dots. Okay, so P, Q, R, S, T, U. Then the number of elements here is 6. Okay, then B, the set of edges. So in this case the edges are not named after E1, E2. Okay, so we will name the edges this way. Okay, so let's see, this line connects P and Q. Okay, so this is how we get this. Then PU, PU. Okay, so whenever we see this, it means there's a multiple edge. Okay, then now QR, QU. Okay, then RS, RT, then S, go back to S. Okay, whenever we see this, okay, it shows a loop. Then ST, and lastly TU. Okay, so now sum of degrees. Sum of degree equals to 2e. So now let's see how many edges are there. There are 10 edges. So 2 times 10, this is how we get the answer equals to 20. Okay, so now if you want to list down the degree of each vertex, okay, let's see vertex P. Here is point P. We can see there is 3 lines here connecting point P, so the degree equals to 3. Then degree of vertex Q. Vertex Q is here. So we can see this is the first line, this is the second line, and this is the third line connecting vertex Q. Okay, so degree equals to 3. Then degree of vertex R. We can see the first line, second line, and third line connecting vertex R. Okay, so degree equals to 3. Then vertex S. Vertex S, here's the first line connecting it. This is the second line, and this is a loop. Okay, so degree equals to 4 because a loop is counted as degree 2. Then degree of vertex T. So you can see this is the first line, this is the second line, and this is the third line connecting vertex T. So degree equals to 3. Then lastly, vertex U. This is the first line, this is the second line, this is the third line, and this is the fourth line connecting vertex U. Okay, so degree equals to 4. Okay, so again, let's go through these tips. The degree of a vertex with a loop in an undirected graph is 2. Okay, one in clockwise direction and the other in anti-clockwise direction. So now let's go through this example 4 together. Draw a simple graph based on the given information. So now we are given the set of vertices and the set of edges. Okay, we will learn to draw a simple graph. So again, every one of us, the graph that we draw is different from each other because every one of us think differently. Okay, so this is the solution given. Okay, first of all, let's see. The vertex are named after 1, 2, 3, 4, 5, and there are 5 vertices. So this is the first point, second point, third point, fourth point, and the fifth point. So we'll name the points as 1, 2, 3, 4, 5. Okay? Then now let's look at the set of edges. 1, 2, 1, 4, 1, 5. Okay? So meaning there's a line connecting vertex 1 and 2, vertex 1 and 4, then vertex 1 and 5. Okay? Then 2, 3, 2, 4. So here is edge 2, 3. Here is edge 2, 4. Okay? Then lastly, 3, 4, meaning there's a line connecting vertex 3 and vertex 4. Okay, so here it is. Then now, let's go through B together. Now, the set of vertices are named after P, Q, R, S, T, U. And we can see now there are 6 vertices. Okay, so now all these dots are the vertices. And we will name them P, Q, R, S, T, U. Then now, this set of edges. First one, PU, meaning that there's a line connecting vertex P and U. So this is the edge, okay? Then PT, then QT, QS, okay? RS, then lastly, RU. So this line connects vertex R and vertex U, okay? So if the graph that you draw is different from the answer given, it is totally fine, okay? As long as it fulfills the condition given, okay? So now let's go through this example 5 together. Draw a graph with multiple edges and loops based on the given information. Okay, so the set of vertices are P, Q, R, S. So we know there are 4 vertices and the vertices are named after P, Q, R, S. So let's refer to the solution given. So P is here, Q is here, R is here, S is here. Then now, let's refer to the set of edges. P back to P, so meaning this is a loop. Okay, there's a loop here. Then PQ, PS, so meaning there's a line connecting point P and Q. There's a line connecting point P and S. Okay, then QS, QS. This means that there's a multiple edge here. Okay, so QS, QS, QR, SR. So QR here, SR here, R back to R. This is a loop. Okay, so now let's proceed with B. V, the set of vertices is 1, 2, 3, 4, 5, 6, 7. So we can see here 1, 2, 3, 4, 5, 6, 7. Okay, then now the set of edges. So 1, 6, 1, 6 here, meaning that there's a multiple edge here. 1, 6, 1, 6. Then 2, 7, 2, 7, again multiple edge. 5, 7, 5, 7, again multiple edge. 3, 4, 3, 4, again multiple edge. Okay, 1, 7, 6, 7. So meaning there's an edge connecting point 1 and 7. There's an edge connecting point 6 and 7. Then 3, 7, 4, 7. So here it is. Okay. So next, example 6. Determine whether a graph with the following degrees of vertices can be drawn. So now we are given the degrees of vertices. Okay, so we know there are 5 vertices now, and each with degree 3, 2, 2, 1, 3 respectively. Okay, so now let's add up 3 plus 2 plus 2 plus 1 plus 3 equals to 11. Okay, but we have learned that sum of degree equals to 2e. So the answer must be an even number. In this case, it is equals to an odd number. So this graph cannot be drawn. Okay? Then now part B. First of all, let's add them up. 2 plus 1 plus 1 plus 3 plus 3 plus 2, we get 12. Okay? So this graph can be drawn because the sum of degree is an even number. Okay? So now we have came to the homework. Okay? So go back, please complete all this homework so that all the knowledge that we have learned today belongs to you. Okay? So if you are having a lot of difficulty in completing all this homework, I have prepared an online course for you guys, okay? It is a step-by-step guideline helping you guys in completing all this homework in the textbook, okay? Including the comprehensive practice at the back of each chapter, okay? So coming next, we'll learn to compare and contrast a directed graph and undirected graph, a weighted graph and unweighted graph, okay? So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, okay? I'll see you in the next video. Bye bye.